Hi and welcome back. So in this video, let's talk about, we've been talking about over the past bunch of videos, valence electrons and how we can predict that, or we can show that how many valence electrons each of these different columns would have. And we said that this column had 1, 2, 3, 4, 5, 6, 7. And as we learned in the last video, everything below helium has 8, and helium only has 2, but helium is happy having only 2. Helium doesn't necessarily want to get to 8 electrons. Helium is perfectly fine just having 2 electrons. So these are the numbers of valence electrons. And what we said was that most elements on the periodic table want, and I'm going to be using that word again, want, and I promise I will do a video probably in the next couple of videos where I will maybe clarify this term want a bit more, but I'll even write it up here. Want. That we learned that most elements want to get to 8 electrons. They want to have a noble gas-like electron configuration. And one of the things that we've been talking a lot, and when we did electron configurations, we talked about nearest previous noble gas electron configuration. And what we're going to find is that when we are talking about how these different elements might want to have an electron configuration like a noble gas, it's just going to be the nearest noble gas. It's not going to be the nearest previous. It's just going to be the overall nearest noble gas. So in this video, what we're going to take a look at is we're going to take a look at sodium, and we're also going to take a little bit of a look at chlorine over here on the other side of the periodic table. So sodium has got 1 valence electron, and let's just go ahead and we're going to draw out sodium's electron configuration. So sodium has got, and let's actually use the nearest previous noble gas electron configuration. We can say that it has neon, and then after neon, it has 3s1. So this is sodium's 1 valence electron. Now let's take a look at chlorine. So chlorine right below it, has again, it's got the same electron configuration as neon, and then in addition to that, what electrons does chlorine have? It's got 3s2, and then it's got a 3p, it's 3p orbitals. They're almost completely full. It's got 3p5. If it had 1 more electron, it would have the same exact electron configuration as argon. So now, let me ask you something. And we are going to maybe, I've got a good video picked out where we will watch an example of this. But let me ask you something. If I was somehow able, I won't say if I put them together, if I was somehow able to get sodium and chlorine to react, and we both know, and we know that there is a strong tendency, that there is a very strong force, and we keep using this word want, and I'll talk more about why we keep using the word want, but we know that both of these elements want really bad, really bad to have noble gas-like electron configurations. So they want, and in this case, both of them want to have 8 valence electrons. What is the easiest way? What is the easiest way for each of these to essentially get that configuration? Keep in mind, sodium has 1 valence electron, and chlorine has got 7 valence electrons. So what's the easiest way? Well, if there was some way that sodium could essentially give this electron, and let me do this in orange. If there was some way that sodium could essentially give this electron to chlorine, then what would happen? Well, sodium, if that happened, our sodium, whatever we're going to call this, whatever we're going to call our sodium atom, it loses an electron, it would have the same exact electron configuration as neon, and it wouldn't have any extra electrons. So sodium would be happy. It would be happy. It would have the electron configuration that it more or less wants. It has a balanced electron configuration. How about chlorine? What would happen to chlorine if chlorine gained this one electron? Well, it would have 7 valence electrons. And now chlorine's configuration, we could say, actually, you know what? I'm going to say chlorine. Maybe I'll edit this. So chlorine plus 1 electron. So chlorine, we're going to add 1 electron to chlorine. That electron configuration is going to look exactly like argon, right? It's going to have the same electron configuration as argon. And similarly, I should have written this way down here. Let me just erase this neon down there. Sorry, I'm going back over this stuff. So if we said that sodium minus 1 electron, so sodium, if we took 1 electron away, that would have the same electron configuration as neon, right? And so now both of these elements, now that chlorine gained 1 electron and sodium lost 1 electron, they're both happy. They both have the electron configuration that they each want. And essentially, what this is when an atom loses or gains an electron. And you can imagine that what charge does an electron have? Well, an electron has a negative charge, right? And a proton has a positive charge. So you can see that if, both chlorine and sodium, both of these atoms still have the same number of protons, but one's gained an electron and one has lost an electron. So both of these atoms are now going to have some type of charge. So both of these atoms, so our chlorine plus 1 electron, and our sodium minus 1 electron, both of these atoms, essentially, after they've lost an electron or lost an electron over here and gained an electron over here, they're going to have some type of charge. And what we call them after they have a charge, after an atom is a neutral atom, and through either losing or gaining an electron, now the atom has a charge, what we are now going to call it is an ion. And an ion is essentially, I'll just define it, it's an atom with an unequal number of protons and electrons. And essentially, you can imagine, I guess, what that is the easiest way that you can still imagine that both of these, the chlorine atom has a nucleus with a charge of positive 17. So we could say that the chlorine atom has a nucleus with a charge of positive 17, and you could say, maybe, even though, you might think that, isn't one more electron too much of a negative charge for the chlorine atom to take on, we're hopefully going to realize that the chlorine atom much more wants to get that electron to have the argon electron configuration than it wants to stay neutral. Similarly, sodium is going to want to lose that 1 electron much more than it wants to stay neutral. So, and therefore and after sodium loses that electron, it has that noble gas electron configuration of neon. So anyway, that is essentially an introduction to ions. Ions are atoms after one has either lost or gained an electron, and it essentially has an unequal number of protons and electrons, and therefore an ion has a charge. It has a charge associated with it. It's no longer a neutral atom. So let me circle this so maybe you can see it a little bit better. So anyway, that is your introduction to ions. In the next video, we're going to talk a little bit more about ions, and specifically we're going to keep working on sodium and chlorine and talk a bit more about the types of ions that form. So anyway, thanks so much for watching, and I'll see you in the next video.